In the words of the wisest of humans, the Blues Brothers, it's hard to gamble when you lose every bet, and it's hard to save money when you 20 years in debt. So today, this is Software Evolution, and we are talking about technical debt. What is a technical debt in general? It's a sort of a vicious circle, the death spiral of software engineering. A developer is in a hurry, they need to finish something quickly in order to ship. They write poor code just because this is the fastest way to get to the desired point or the point of shipping. Then that means that poor code is already in the code base, and the next task that the same developer or their colleague is taking takes longer and is harder to do and brings them further into depression and burnout, which means that the system cannot evolve timely anymore, which means that the business side suffers and the company makes less money, which means there is less money for development, which means that developers get more and more overstressed, overworked, and less efficient. So technical debt is not a different fancy name for defects. This is a specific kind of process that happens when you are trying to borrow from yourself, from your future, and then you get yourself in a situation where you need to pay interest. If you're not paying interest, this is not debt. So let's talk about the backlog, right? So backlog is sort of this thing that everybody has when they're developing or when they are following a course or writing their thesis or anything that we are doing. The backlog is sort of things that you know that you should be doing very soon or you should have been doing recently, but you haven't done it yet. So the best part with that is something that's visible and something that has a positive value. For instance, a feature, right? So this is a visible feature that the users want, and you haven't implemented it yet, but then you can put the effort in it, and then by doing that, you're doing something visible. So everybody will be happy, the users will be happy, the managers will be happy, you will be happy. Right? So that's the part that in many issue trackers and backlog trackers is marked with green because this is a feature and feature is good. Everybody loves features. What if it's something is visible but then has negative value? Well, usually we call these things bugs. Unless you can disguise a bug as a feature, then it will be and it stays a bug. That means that your users, they have some negative experience with your system. They know that if you do a particular concatenation of actions, at some point it brings them into an uncomfortable position. It crashes or it loses data or it misrepresents something and so forth. And then you need to fix it, right? So you put an effort there. Again, it's maybe less comfortable to work with a bug, but as a result, you get something visible, which is still good. It's just that there was negative value and you're working to remove the negative value, and then you fixed the bug and everything is fine again. So if feature is everything is fine and I want to make it even better, the bug is everything is bad and I want to make it normal again. Yeah? What if something has a positive value but is invisible? Something that, the developers, pretty much all of them, they enjoy that, and the managers, they don't, because they cannot see this, they cannot advertise it to the customer, right? That's usually something that's related to the architecture, right? So it can be also a feature, but it's an architectural feature. It's something that improves maintainability, or you're adding tests to your system, or you are making a new module, or you're creating some classes, or I don't know, there can be many activities that improve the architecture of your system, and they bring positive value into the system, but they are not immediately visible to the customer. And the last part, which is invisible and has negative value, that is where technical debt is from. So you know that something is bad on in the invisible parts of your system, well, invisible to the customer, right? And it slows you down. It makes your actions as a developer or as a maintainer or whatever, as an engineer, it makes your actions less efficient, and still it's there, still it's invisible. So if you get away from it, if you fix it, nobody will see it. You will be less burdened, but nobody else will see it exactly. So there's in this backlog classification in this quadrant, which I borrowed from Philip Kruchten, who is a very nice, very good expert in the level in the area of technical debt. The good thing about this one is that pretty much every corner of this classification of backlog issues has their own stakeholders, people who really care about that. Right? So on the architecture side, right, you have well, if not all developers, then at least the architects of the system. They really care, and they really prefer to work on improving the architecture, also because they know that that would make the system better in the long run, that you will be able to do more stuff later. On the green side, on the side of the feature, you have usually managers, right? Because this is a very comfortable thing. You can go to the customer and say, well, what the system could do last week, but this week we can do the new thing. Right? And as you know from the laws of software evolution, the more often you can go to the customer and say that, yes, I have new stuff, this is more goodies, now you get the same for the same money, or maybe slightly more, that you get more stuff, the more they perceive the quality of the system going up, or at least not going down. The red part, the bug part, has as a stakeholder, the user, right? Because it's the user that complains, is the customer that complains about something, and then they really care about you fixing the bug and making their life great again. Who is the stakeholder in the last corner in the technical debt? Well, nobody. That's the entire point of the horrible nature of the technical debt. Nobody is interested or in diving into something that is bad and invisible to the customer in order to make it slightly less bad and still invisible. Right? This is the most uncomfortable thing to work on out of these four, and you get basically no credit for it because it's invisible to the customer, right? Let's have a deeper look into technical debt, because not all technical debt is created equal. This picture I borrow from Martin Fowler, who is also a well-known figure in software engineering, and this is called the technical debt quadrant. So first of all, the easiest case, when we are being reckless and we are being deliberately reckless, right? So we know that this is a bad thing, but we say, we'll deal with it at some point. I don't know, maybe not, but it's sort of okay if you break the rule now and then, right? For instance, you can, by using also my example from the beginning of the topic, you can say, well, we don't have time for architectural considerations, design, refactoring and whatnot. Let's just ship it now. Let's just do the coding and give it to the customer. That's it. We need to ship today, right? We don't have time for design. This is being deliberately reckless. You know that you're doing a bad thing and you're still doing a bad thing, right? A variant of this is when you're being careful and you are still being deliberate in doing something bad, but you're being careful about this. For instance, you can say, yes, okay, we ship now and we clean up later. Right? We today is the Friday, and we need to ship now because then we get the payment for delivering it this week. Then we can run some tests, or the customer can run some tests over the weekend, and then we can also use the weekend for overtime activities and to clean it up maybe a little bit before Monday. And we will definitely put more time on this on Monday. We will plan for it now, but we still put some suboptimal code or some bad decisions into the software. So that's being careful deliberately. We also can be accidentally careful, right? And accidentally careful means that We didn't know that we were doing a bad thing, but now that we've done that, we will know for the future. So if in the future the same situation arises, then we will think twice, maybe thrice, before we actually take the same decision. Or maybe, hopefully, we'll even take a different decision, right? And finally, you can have accidental reckless, and that's the worst type of technical debt, because then basically you're doing a bad thing without even realizing it, right? You're like, okay, inheritance what's code reuse, right? What's this database thing that you're talking about? I was always writing stuff just in a textual file, right? In a comma separated values. Nothing can go wrong with comma separated values, right? And well, that usually happens when the expertise level and depth of the people who are implementing the system does not correspond to the requirements of the implementation of the system. And the last picture that I want to show you before closing up for conclusion is also from Philip Kruchten with co-authors, and it's about the technical debt landscape. So you have things on the visible side of the evolution. So here you see they are distinguishing between evolution and quality. If you've noticed, I usually consider them together because it's very hard to see the point where one becomes the other. But you can sort of if you separate things that are really defects and bug fixes and things that are introducing new features and adding functionality, if you can separate them, then yes, you have two different sides. One is the good form of evolution where we just pushing the functionality up, and the other one is the quality side where you are maintaining the system and you're struggling to keep it running, to keep it well. Right? So low external quality is, as you remember, is something that you can measure from the outside. So the system is behaving slow, for instance. That's the easiest example, right? It's slow, so figure it out. Fix this. Or it's a defect, right? I click there, it crashes, right? Fix it. Right? On the new features also, so the programmers have made it so that there is now a new button. If you click on it, new stuff happens. It wasn't possible in the last version, now it's possible. Good, visible, nice, right? All these things are visible. Visible to the customer, visible to the developer, visible to the manager, and all kinds of other stakeholders. But there are also a lot of things in the middle. They are sort of sometimes maybe visible and maybe not, and there is a spectrum, and in some on the side of the evolution you have more like architectural things, and on the side of the quality you have more like code level things. But in general, on all parts of the spectrum you can have something like smells, right? You can have a code smell. It works. For instance, a code smell, the simplest one, duplication, right? Copy paste. So you have several pieces of code that are exactly the same and they are present in different places, right? It's there, it doesn't harm the performance of your system, probably, but it is a ticking bomb, because if at some point, if you discover a bug in one of them, you will probably forget to fix it in the other version of the same code, because they are separate and they are stored in different places. And unless you have very good tool support, nobody will tell you that you also need to fix the other one. And then it starts to give you issues for tomorrow. Or you can just have, the code that's way too complex, right? So for instance, you've put too much functionality into one element of your system, and that means that it's very complex, and that means that the next time something goes wrong with it, you will have to spend much more time looking into it and probably also cutting it in pieces just in order to understand it. So again, you have permitted your code to grow more complex, which means tomorrow, if you get a feature request or a bug request, you will have to spend more time first paying this debt back and then fixing the things or implementing a new feature. You can also have debt on in tests or in documentation, like I will document it tomorrow, or the tests debt, right? I will adjust the test. They are red, but that's because I changed things, right? I renamed something and now it doesn't work. I'll fix it tomorrow, maybe, but maybe before you pay it back, before you fix it tomorrow, then something will arise that will. That would have been caught with these tests had they been green, as all tests should be. Right? And if they're not, then you don't see the problem. So all these things in between, they are sometimes hidden and they lead to technical debt. To conclude, if you do something that's good for the short term and bad for the long term of your project, then you are accumulating technical debt. Bad decisions that you take now, they borrow from your future development time. So for a short running prototypes, for instance, or for short running throwaway projects, or for something that needs to be shipped and then never looked back at again, this is fine. Then you borrow something and you never have to pay it back. The moment you are paying the interest back, that is where you have the technical debt. So you can have bugs and you can have features and they're all visible and this is nice, but your architecture usually is not visible to the customer. So it's much harder to argue for the customer, argue for the manager, argue for all the other people who are not looking at it right now, including your colleagues who are other developers. Right? It's very hard to argue for them from your point of view that you need to spend more time on that. And if you're doing it the good stuff with the architecture, that's just you're implementing architectural features. And if it's architectural bugs, let's say, then that is technical debt. It can come from code smells or data smells or test smells, documentation smells, whatever. They can come from bad coupling or modularization. They can come from requirements creep, right? You started developing a bit too early. You didn't know what you're building and now you've built the wrong thing. It can be also coming from just a series of local changes where you're changing things locally without thinking of the global architectural evolution or without thinking of reuse. Maybe you've implemented the same little algorithm 5 different times, which work slightly differently in 5 different places. And at some point, you will need to merge them just because this is a ticking bomb, right? It could be a delayed refactoring, something that you tell to yourself that you will fix it tomorrow. And maybe not. If you need to pay the interest before this happens, then the cost of the things that you will be doing will go up because you're also paying interest, right? And there is a scale of different things, and usually architectural debt is the most expensive one, and the code debt is less expensive. Also, simply because when you see the code, that's it. This is the code. You see that code. This is the code that gets executed, right? You see that it's bad. You make it good, and that's it. You paid it back. For the architecture, sometimes it's not that easy to see where the problem lies, and you need to spend more time on getting that information out of it. The bad news with technical debt is that, you remember this SPE systems and whatnot, and I was saying that some of them require evolution, some of them not. All systems accumulate debt. If you're doing something to the system, or if the system is involved in something that is being done around it, it will accumulate some technical debt, at least if you are not careful about it, which means you're not actively looking for some sources of technical debt and you are paying that debt back before it accumulates interest. Right? So if something is not incurring any interest, then it's not a technical debt. I'm talking about things that really make you pay with interest tomorrow or maybe the next month or the next year. Have fun. Don't get too deep in technical debt. If you need me, you know where to find me.